Hello guys, in this video we are going to discuss the solution of the problem populate in order successor for all nodes. So let us look at the problem statement. The problem statement says that given a binary tree, complete the function to populate the next pointer for all nodes. The next pointer for every node should point to the in order successor of the node. You do not have to return or print anything, just make the changes in the root node given to you. The node having no in order successor will be pointed to -1. You don't have to add -1 explicitly, the driver code will take care of this. So for instance, if you take the first example, the in order successor for all the nodes will be, for 3 it will be 8, for 8 it will be 10, and for 10 it will be 12, and that is what is being printed over here. And since for 12 there is no successor, that is why we are printing -1. But this -1 we don't have to print it, the driver code will take care of it. So that's about the problem statement, folks. Now, before we begin discussing the solution of it, let us take a look on the node data structure. So if you see the node data structure, the value is here and it contains 3 pointer: left, right, and next pointer. So what we need to do is that we don't have to make any changes in the left or the right pointer. We just have to make necessary changes in the next pointer. So that is one minor detail which I wanted to highlight. Now let us discuss the solution of this problem. To discuss the solution of this problem, let us take an example. So let us say this is the tree which is given to us, and what we need to do is we need to manipulate the next pointer of each of these node such that the next pointer points to the in order successor of the tree. So from here what we can conclude is the first thing which we have to do is the in order traversal. So if we do an in order traversal of this tree, the nodes which will be printed will be in this order. So the first node will be 3, then 8, then 10, and 12. For now, the next pointer for each of these nodes is pointing to null, and what we need to do is we just have to manipulate the next pointer rather, in order to point to the next element, or in order to point to the in order successor of the binary tree. And the way we will be able to manipulate the next pointer is by keeping a track on the previous pointer. So what I'm trying to say over here is, first we are going to perform an in order traversal, and while performing the in order traversal of the binary tree, we will keep a track on the previous pointer. So let us see how, while performing the in order traversal, we'll keep a track on the previous pointer. So to begin with, the previous pointer will point to null, and we will perform our in order traversal. So for in order traversal, we will be at this position, and over here the previous is null. When we will move to the next pointer, which is 8, then the previous node will be 3, and similarly when we'll move to the next pointer, which is 10, the previous pointer will be 8, and similarly over here it will be 10. Now, since we have the previous pointer as well as the current pointer with us, all we have to do is we just have to make this adjustment, which is the next pointer of previous should point to the current node. So 3 next pointer will point to 8, 8 next pointer will point to 10, and 10 next pointer will point to 12. And in this way we will be able to manipulate the next pointer such that it points to the in order successor of the binary tree. And that's the general idea behind solving this problem. So now let us discuss the pseudocode for this problem and see how we will be able to manipulate the pointers. So let us say a successor function is there and the root node is given to us. Here what we are going to assume is we have a global pointer with us which is previous, and the initial value of this global pointer is null. So the first condition is if the root equals to none, then in that case we can just return from the function. Otherwise we will perform the in order traversal. So the way we will perform in order traversal is essentially successor of root.left, and after performing root.left, here there are some manipulation we will do, and we will see about that manipulation, but then towards the end we will just have to call the root dot right, and in this way we will be able to perform the in order traversal. Now let us see how we will be able to manipulate the pointers. So the first thing which we are going to check is, so if previous equals to none, then let us initialize our previous pointer. So in such case previous will equals to root, otherwise we just have to manipulate the next pointer of previous. So the next pointer of previous will point to the current node, and the current node is root. And then towards the end, we just have to update our previous node. So previous equals to root. And in this way, we will be able to adjust our next pointer. So that's the pseudo code, folks. Now let us see how we have implemented this in Python and C++. So let us first take a look on the Python implementation of this code. So we have implemented this successor function with us. Root is what is given to us. If root is equals to none, then we are returning from the function. Otherwise, root.left and root.right in order to perform the in-order traversal. And over here, we are manipulating the pointers. So if previous equals to none, then we are just initializing the previous node. Otherwise, the next of previous will point to the current, which is root, and then we are updating our previous pointer. So that's the entire code in Python, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same. We have our successor function with us, and a global variable which is previous, and the initial value for previous equals to null. Then we are checking whether root equals to none. If root equals to none, then we are returning from the function. Otherwise, the in-order traversal. And over here, we are manipulating the pointers. So if previous is not equals to null, then in such case, previous next points to the current node, which is root, and then we are updating our previous node. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.